Welcome back. I am absolutely thrilled to bring you today's explainer because we are stepping out of the bleachers and going straight into the high-tech, digital VAR room. Today, we're going to forensically break down a massive, defining moment from the 2026 World Cup match between Portugal and Croatia. We aren't just looking at the players on the pitch, though. No, we are looking at the invisible, underlying data analytics that literally decided the final outcome of the game. Think about it. Billions of people were watching this match worldwide, completely unaware of this silent digital reality unfolding right beneath the surface of the grass. So get ready, because we're about to look at elite sports in a completely different way. Okay, let's dive into this. To really understand what happened in this match, you kind of have to picture the ultimate contrast. On one hand, you've got the macroscopic reality, right? A massive, echoing stadium, tens of thousands of screaming fans, the palpable human emotion of a tense World Cup clash. But on the other hand, running parallel to all that chaos is a completely silent, ultra-fast world of data processing. So the core question we're answering today is this: how does a microscopic signal, literally a blip of data completely undetectable to human senses, manage to silence that massive crowd and overturn a World Cup goal?
Section 1. The Late Match Incident.
Picture this. It's late in a match, and tensions are at an absolute peak between Portugal and Croatia. The ball is played forward. A Croatian attacker makes this brilliant run, connects, and boom, sends the ball right into the back of the net. To the naked eye, to the fans going wild in the stands, and to the referee sprinting down the pitch, it appears to be a perfectly legal, game-deciding goal. The stadium just erupts. But let's strip away all that noise for a second. Let's look at this timeline and isolate the variables. In real life, it's a blur of motion. The midfielder spots the gap, the ball is struck at T-500 milliseconds, it rips through the air at T-200 milliseconds, the striker meets it, and at T0, the ball hits the net. Goal, right? Well, actually, scratch that. What the human eye perceived as a fluid sequence of brilliant football was immediately intercepted, chopped up, and analyzed piece by a silent network of sensors. While the players were literally still celebrating, the algorithms had already gone to work.
Section 2. Connected Ball Technology.
Now, to really get this, we have to pivot away from that wide-angle macro view of the stadium and zoom all the way in, past the players, past the grass, right into the center of the match ball itself. Because to understand the officiating in this match, we have to look at the invisible architecture that actually changed the game. Connected ball technology. And this brilliantly illustrates how a simple piece of sports equipment turns into a highly advanced smart object. Embedded deep within the ball are these high-frequency sensors. Now, these aren't just tracking where the ball goes, they're tracking what happens to its surface. These sensors are designed to detect micro-contacts. We're talking about grazes, deflections, tiny touches that are entirely invisible to the human eye, all while broadcasting real-time signal processing data at just incredible speeds.
Let's compare these two realities side by side because it's wild. On the one hand, we have the human eye. Now, no matter how elite a referee is, they're relying on subjective interpretation from yards away while running at full speed. Human eyes process visual information at roughly 60 frames per second? So they are fundamentally blind to microscopic contact. But on the other side, we have sensor telemetry. These sensors are broadcasting at 500 Hz, meaning they are capturing data 500 times every single second. This is cold, hard, objective, data-driven by physics-based algorithms. It doesn't blink, it doesn't get distracted by the crowd, and it doesn't guess. During that late Croatian goal, the human eye saw a clean play. The sensor telemetry, however, felt a micro-contact on the ball right before the final strike, a touch that changed the entire legality of the play.
Let's move to Section 3, Automated Offside Tracking, and see how this builds.
Because you see, knowing the ball was touched is really only half the battle. To enforce the rules, the system needs to know exactly where every single player was at the exact millisecond of that invisible touch. That requires a second, equally powerful layer of technology working in perfect sync. We're talking about semi-automated offside technology. This isn't just a few cameras rewinding tape, folks. This is a live, geometric pitch mapping system. It tracks the players dynamically, utilizing hyper-precise limb tracking. The system knows exactly where a player's shoulder, knee, or toe is at any given fraction of a second. It creates this objective, three-dimensional automated map of the pitch. So while the ball is broadcasting its micro-contacts, the stadium cameras are simultaneously mapping the exact physical coordinates of every Portuguese and Croatian player.
Section 4. Fusing the sensor data.
This is where the true magic of precision officiating happens. It's all about the signal pulse. Having a smart ball is great, sure, and having player tracking is great. But the definitive answer only arrives when you crash those two massive data sets together. Think of this process exactly like a machine executing code. Step 1.
The ball's high-frequency sensor detects a micro-contact, that slight, invisible deflection by a Croatian player in the build-up. Bam, a digital timestamp is instantly generated. Step 2. That specific timestamp triggers the semi-automated offside technology, pulling the precise limb tracking data for that exact millisecond. Step 3. The offside frames are snapped into place. The geometric mapping reveals that at the precise moment of that invisible micro-contact, the receiving Croatian goal scorer had a limb leaning just barely past the last Portuguese defender.
Section 5. The automated verdict. At this exact moment, the fans are still cheering, the players are celebrating, the human officials are literally resetting for the kickoff. But inside the system, the forensic reconstruction is already complete, and the algorithms are ready to deliver their final, undeniable result. Verdict: goal overturned. So, the crucial point is this. This wasn't based on a referee's gut feeling, not based on a blurry television replay. It was overturned based on precise impact telemetry fused with objective limb tracking. A microscopic fraction of a second and invisible grades of a football was successfully captured and quantified by the system, objectively overturning a macroscopic, game-deciding World Cup outcome. Just incredible. Now, what's really interesting about this is how data analytics researcher Habtom Shnash-Abrha frames the significance of this event. He calls it the shifting paradigm toward objective, automated decision-making in elite sports. This match between Portugal and Croatia wasn't just a game, you know? It was a technical case study. It proved that real-time signal processing and physics-based algorithms can successfully intervene to ensure absolute fair play, even in the most high-pressure competitive environments on the planet. The technology completely removed human error from a virtually impossible call.
Which brings us to our final thought for today's explainer. If invisible sensors, geometric mapping, and physics-based algorithms can perfectly guarantee fair play in ways the human eye simply cannot compete with, well, is the era of subjective human refereeing officially over? Are we really looking at a future where sports are officiated entirely by silent, invisible data? It is a deeply fascinating question to ponder as technology continues to just totally reshape the games we love. Thank you so much for joining me to break this down today, and I'll catch you in the next explainer.